Hello and welcome everyone, this is Dmitry. We are having another network programmability stream, and today I am so excited because for the first time in 2 years, we will have more than myself on the stream, we'll have guests on the stream. And not only that, but we will be exploring a product that hasn't been released yet, so it's twice exciting as usual. So we will be exploring the new version of VIRL today, which I think is quite amazing. We'll see a lot of stuff about it today. And before we do that, let me actually go around our virtual table and let's introduce everyone. So if you could say a couple words about yourself, that would be awesome. Starting with you, Simon.
Voice phone me in first. Let me wake up. So I'm Simon Knight. I'm one of the software engineers working on the VIRL2 product, and it is early morning for me, so I'm still waking up.
Perfect. Thank you, Simon. Do you mind also sharing where they can find you on social media if you want to be found?
Not overly, but I'm SK2ESKEAYEWO on Twitter. And by the way, Vern's just joined the call as well, Dimitri, so you can introduce him.
Okay, perfect. Thank you, Simon. Justin, you're up next.
My name is Justin Guagliata. I'm a software engineer working on VIRL2 for the last few months now, and you can find me on Twitter at BreakInTheWeb.
Perfect. Thanks, Justin. Ralph.
Yeah, I'm the one with the German accent. I'm Ralph Schmieder. I'm based in Germany. I have been at Cisco forever and doing like all sorts of different things, software development as of late. And yeah, I'm the janitor here. Like I do pretty much everything. So yeah, I'm pretty excited to have this thing where it is right now. And so looking forward to it.
Perfect. Thank you, Ralph. Vern.
Hey guys, I'm Vernon Palango. I'm the product manager for the VIRL product, and I've been with the product since September, so I'm relatively new. And I'm excited as well because we're getting pretty close to release, and my Twitter handle is vpalango.
Perfect. Thank you, Vern. And myself, I'm Dmitry. I will be a host for today. You can find me at DMFigo. All right, and chat. I would like you to say thanks to our guests for joining, and especially considering that we have such big time zone differences. So Simon is in Australia right now, enjoying or not enjoying his morning, early morning, and it's the rest of. Justin, where are you based right now? Are you in France or you're in?
Yeah, I'm based in France.
Yeah. So
France.
the rest of us are here in Europe, enjoying our evening. All right. Let's get started. And I think the best way to get started will be to kind of like go through like how I got involved with the VIRL2, because I've been trying to get these folks and get this stream for more than a year now. So I'm very happy that we finally managed to get it done. Yeah, and I think I first heard about the new iteration of VIRL back in December, and December, I think it was 2018, so more than a year ago. And it was a colleague of mine who said to me, "Hey, have you seen a new VIRL?" And I was like, "No, there is a new VIRL." And yeah, and he told me, and he got me in touch with Ralph and Simon, and I was checking it out. And if you guys know me from the stream, like I'm kind of skeptic, right? So I was like, I didn't have super high expectations, right? Um, but after using it, after especially hearing about its architecture, right? Because I'm personally a software engineer, so I was very curious about what is running on the back and how it was built, because I can also kind of evaluate make some educated guesses about the scalability or about like its performance and stuff like that. And when I first saw it, I was actually, when I started using it, I was very impressed by the very early betas that they had. And especially when I heard that there was no OpenStack, it also made me believe that it's going to be interesting product. All right. And Simon and Ralph, why don't you tell us a little bit more about how you got involved into developing VIRL2 and how you came up with this idea? I'll start with Simon.
Okay. Always me. Yeah, so I've been working on the VIRL, what is now VIRL1, for 5 or 6 years, primarily around the config generation. That's how I started getting involved, carrying over some of my research. So I was AutoNetKit, and then the live visualization piece, which is kind of the opposite end, but similar, of AutoNetKit. So rather than generating configurations, we were logging in, scraping the network config, or the network output, and the CLI, parsing that and visualizing that. And there's much better tools, like network DevOps wasn't really a thing back then. And playing around with some of those pieces and trying to automate and build on top of it, and it was starting to become clear to me some of the challenges with what we had in terms of the APIs and the user interface, and a lot of these pieces that were based on some of the technology choices. So we started exploring as a proof of concept whether we could rebuild the core middleware on top of libvirt directly based on some of the experiences that we'd learned from the architecture and approach of VIRL1 and the user interface. So essentially we started building some proof of concept and then building some of the UI based on the web UI stuff we'd started doing in VIRL1, and kept building and building from there. And yeah, the main focus was to try and really simplify. We've been to Cisco Live US and then some of the other ones, mainly each Europe one, and then a little bit of Australia and Latin America for 5 or 6 years now, and been very active on, we might not be posting, but reading the community feedback on Reddit and Cisco Learning Network forums and Twitter and blog posts and things like that about where people felt the strengths of VIRL were, where people felt the challenges were, and where it compared to other products in the space. So it was kind of a mixing together of our own personal experience, the feedback from internal customers, the feedback from people like Dimitri, where they felt that other products in the space had technical advantage or design, better design in some aspects, and trying to really build all that into initially that proof of concept, and then expanding that out to build it into a prototype, an MVP, get some internal people involved like Dimitri and others, and then building that into the product we have today. So lots and lots of iterative development, bearing in mind the feedback we've received on version 1. So we really got a lot of knowledge about what does and doesn't work for version 1. Tons of feedback on the online forums, the Cisco Live, and building that to start to build ideally a really solid platform. And I think 2.0 is getting us a lot of the way there. And what's really exciting is the design and the architecture that we've built up that we can really iterate further and further. So we've got what we feel is a good product, and hopefully everyone else can get it soon and feel the same way. But there's some really interesting stuff that we can start to add in the future, and really keen to hear how community use it and their feedback and things like that. Is how we develop there. And then before we hand it over to Ralph, the other thing that really kicked it off once we had that initial kind of proof of concept, okay, this seems viable, let's see what we can do. We did have this very early diagram that we should dig up again sometime of
I have it.
Make it a
I have it. Ralph sent it to me.
Yeah.
I am actually trying to put it on.
So you're
the
going to
screen.
see that for the first time, like in a long time, Simon, right? Because I always kind of hid it from you.
So the idea was to build like a very modular architecture so that we could have very clean differentiation between the different components and different modules. So we spent quite a lot of time in the early days with whiteboards and trying to really sketch out an architecture that would let us do lots of different potential deployment scenarios, whether it's libvirt or pushing to something else is always an option, or trying to integrate hardware, all these sort of things. No idea whether they're going to hit the product roadmap, but technically we're not going to be too constrained if we want to explore those options in the future. Whereas VIRL1 was very much specifically trying to hit a certain product point, and technologies evolved since then quite a bit. So we've got a lot more technologies we can use. But yeah, this is the one. So essentially, we're trying to have a this kind of, you know what you call it, this kind of very sketchy napkin diagram of how it would work, and we've hit pretty close to it.
Simon, let's switch to Ralph. I want to also hear his side here.
Yeah, sure. I mean, I got involved into this entire thing back in the days when I was doing some TME work on a totally separate, or within a totally separate business unit, and covering totally separate technologies for the most part. And some of the stuff that was quite interesting here was that we could use and leverage such a platform as VIRL to support my work back then as a TME. And then I got more involved into this thing, and I realized that there's a huge potential in this kind of technology. And then at the same time, we were looking at this behemoth, this kind of monstrosity that OpenStack actually was, and the drawbacks that we had to suffer from by the resource usage of OpenStack, and all the complexity that came with OpenStack. And so we sat down at some point, and we had, I think this was basically in maybe 2017, maybe even a bit earlier, where we sat down and said, okay, so what would we do if we would not have like all the baggage and all the like the things that had been already designed into the product? But what would we do if we could start from scratch? If we could build something from the bottom up, and how would that look like? And so this is one of the very early drawings that we did. And so you can already see that this is a layered architecture that we had in mind here. And that green thing at the top, like this green kind of L-shaped thing, which says API, that's basically the core of, it's not the core, but that was kind of the principle that we wanted to implement here, that everything that is done with the product is API driven. And that's still one of the core principles of the product, that we want to have everything done via a well-defined, well-documented, and easy to use API. And then whether this is some automation tooling or CLI that could drive the product, or the actual web UI, which is the primary means to drive the product when we get out of the door with it. But pretty much all of these different use cases, they should use the API. And then underneath, we wanted to have a controller that has some sort of abstraction, and like the let's say high-flying idea here was that controller then has distinct drivers to drive different compute instances underneath. And then, as you can tell, there's right now in this diagram, there's like KVM and ESXi and VirtualBox, and ideally something in the cloud in the future. If you really think big, okay, a driver could also drive VMs in the cloud. And then we developed certain ideas around use cases that we wanted to have in the product, and that's basically what those colors are for, like a personal use case with a laptop, or like more a corporate or service provider use case with different, a different aspect of the product that could be used to drive such a use case. And we also wanted to be scalable so that we can scale this entire architecture horizontally. And obviously, like, not everything that is on this picture has made it into the product as of today, but that doesn't mean that we are not capable of doing something like ESXi in the future if we see the demand, or if we see that we have to have a different compute underneath. And right now it's pretty much like the left side of this diagram that we have implemented, which is libvirt KVM. But the key here is that this driver that is in the middle there that says, okay, drive KVM, that thing has been custom built by us, purpose built, so that we have the performance that we do need, and also do have the capability and the abstraction in there without going very complex like OpenStack in between, which is, it might have sounded a bit like, very negative in the beginning, but OpenStack might be a really great tool for a specific purpose, but it's not a great tool to drive network simulations, because we have a very specific purpose, and in that particular case, OpenStack is just too complex and brings in too many components, which eat too much memory and CPU cycles, which we could better use to drive actual simulations or routers or switches and so on and so forth. Yeah. So this is something that I have dug up from my hard drive, very deep. I just moved to a new laptop a couple of days ago, and I cleaned up the closet basically, and so I stumbled across this thing, and I thought, nice. Yeah, that would be a good occasion to actually show to you guys, because this is truly like 3-4 years old, this thing.
So, Ralph, yeah, and I remember when you were installing VIRL2 and launching it for the first time, especially if you were like on a laptop or on a desktop without like a lot of resources, and you already like 7 gigs of RAM were taken by OpenStack or something, right? That was it the case? Yes. Yeah, it was.
Yeah, that was
painful.
pretty much true. Yeah, so you had to install that virtual machine, and then it had to bring up all these OpenStack services, Neutron, Nova, Keystone, and all these other very capable components. But each of these components were like, using hundreds of thousands of, not each of them, but you get the idea. They are very complex, and so you bring up a VIRL2 machine, and it does nothing. And just by spinning up all these services, it uses roughly 6 to 7 gigabytes of memory without having launched any network simulation at all at that point, right?
Yeah, that was quite painful. Now, another thing that got my attention and my interest was the thing you mentioned around the API layer, right? So, am I understanding this correctly, that even back in the days in 2017 or whenever that was, you were already thinking about if you were to rebuild this VIRL, right? It would be fully API first design, right? It would be fully driven by API, and then like everything else comes kind of like on top of it, right? Like you wouldn't have, like API first architecture, right? Or API first principle. Is my assumption here correct?
That is exactly right. That was the idea back then, that we wanted to have APIs first, and we actually went out to figure out how we can have everything API driven in a way where the API is, so basically what we did is we are using OpenAPI to define the API first. So the API is a big JSON, or YAML in this case, data structure that defines the entire API, and then everything else follows that central data structure that defines the API. And so we are using some tooling in Python for that purpose. So that gives us the documentation as a side, or like as a nice side effect, sort of, where we have Swagger documentation just from creating that API definition, and then all that is needed is to hook up the actual implementation of these handlers for the API into the code, which made us very so it allowed us to accelerate pretty fast to implement all the APIs that we need to drive the product.
And also related to it's not just about throwing the Swagger an open API on top. It's also about trying to really put the focus into getting the right data models exposed up to the user and the right concepts to make it easy to operate with those. So what the concept of a lab, the node, the links, how they all fit together. So it's one thing to have an API, but to try and make something where the objects exposed make intuitive sense to the user, we tried to put a lot of effort into that. So it's not just the mechanics of interacting with it, but it's also the semantics of the things that you're interacting with mapped fairly cleanly to people to build on top of. And we've already started to see some people building on it with some of the ecosystem, which we can cover later on. But that's really positive to hear that people are already using it. So trying to make that focus on usability, and that goes across the whole product, whether it's the UI or whether it's the API and the tooling built on top of it. Really trying to put an emphasis on strength and robustness, but also the ease of use.
Right, but it goes into that direction of the API definition, because part of the API definition is also the schema for the data models, and they are also modeled in Open API to a large extent. So that goes hand in hand with that definition and that kind of independence that we do have by doing that in let's say as a first step to define these models, to define the APIs, and then write the code basically around it.
Got it. Thank you for your perspective. Yeah, and also I remember myself trying to use API of VIRL2. That was not a really pleasant experience. Yeah, all right. Thank you for this bit of history. I think, yeah, I think what we could start with is show people first like installation process. It's actually very simple, and then like go through different features of the product. And here, guys, I actually have a very interesting story from yesterday. So I was preparing for the stream, and I was checking the latest version of VIRL, and I was reinstalling some stuff because I actually was using some older version, right? And it was funny, I was discussing in this Simon yesterday. From the moment I downloaded the OVA file, right, and I started installing it, till the moment where I got fully booted router with external connectivity, so I could actually connect to that router from outside, right? It took me 12 minutes, and I wasn't even like, it was not the goal, right? It was not the goal to make it as fast as I can. It was just, you know, I wanted to prepare for the stream, and that was my goal, right? So it took 12 minutes from when I started installation process till I got the fully running CSR 1000V with external connectivity. So that is, I think, quite impressive. So yeah, let's actually go through installation process really quick. It's quite simple. So I do have OVA somewhere on my disk. Yep. Okay, so I have this OVA. I will import it like test here, and because we already have one VIRL instance running. There's a question in the chat. Sorry if I missed it. Is VIRL2 released yet? It's not yet released, and we'll talk about less technical things like licensing, price, release date briefly with Vern, but just a little bit later. I will change here the memory. I will give it not many resources here. So, oops, let's do 5 gigs. I hope my stream will not crash with all these VMs running at the same time. Okay, and I think I need to, yeah, so one of the things that you can do while you are importing this is, well, setup networking is very useful. Yep, so setup NAT. And another thing would be ISO, right? So right now in the when you install it, you install separately core, right? And all of the images, they are actually bundled in separate ISO which you mount. So those two are completely separate as of now. And while, no, let me actually finish this and then we'll talk about some of this related stuff here. So if I select an ISO with the images over here, I'm actually curious if these two processors and 4 gigs will actually even run. And then I can power this on. Okay, and there is a warning about the AMD processor. So actually, folks, for those of you who follow me and follow my streams, you know that back in August I built this new computer, and one of the purpose of doing that was to actually run a lot of virtual machines and labs and all that, and games as well, and streams without caring about anything. So this machine has one of the latest AMD processors and a lot of RAM, like 64 gigs of RAM, where I'm streaming from. And if you ever tried running any network simulation tool on AMD processor, you probably know that you need to do something to make it work, right? I was actually having a stream about GNS3 on this computer, but together with Ralph here, he did some magic, and now it just fully works out of the box. There is still this message that it's not fully supported and tested, but it's working. Ralph, would you like to talk briefly about that Ryzen support?
Yeah, sure. It was just, some of the stuff that needs to be done to figure out whether the hardware acceleration features and the nested virtualization features are available in the CPU. So we had some code in there that does check whether the CPU supports this stuff to ensure that if you install virus, like at this point in time where the installation right now sits, if he clicks on continue or hits the keyboard to continue that installation dialog, then the system will check, okay, what kind of CPU is in there, or not necessarily what kind, but is that acceleration feature available in the CPU? And we check that, so to ensure that if you do not have that feature enabled, let's say you don't have that feature on your CPU, or you haven't turned on that property within the VM to expose that feature from your CPU into the VM, then we say that to the user, and then it will stop to install it, because otherwise it does not make any sense to continue with the installation just to give the user then later on an error message that says, you cannot launch anything in here because you don't have the capabilities in the CPU. So we have some code in there that does that check. Now on AMD CPUs, it looks slightly different. So they have different flags, and they also have some sort of machine-specific registers. That's the thing that is really like the key here for this particular AMD problem. MSRs, machine-specific registers, which is something that is slightly different between Intel and AMD CPUs, and newer versions of QEMU, they are looking at those MSRs, and if they are not present, then QEMU basically says, I cannot launch any virtual machine on this thing. And then we figured out, okay, so there is something that can actually be suppressed in the kernel module. When you do load that stuff into the kernel, say, okay, ignore all these MSRs, the machine-specific registers, and just don't care. And at that point in time, all the AMD stuff was working as well. So that was just set the right flag in the right kernel extension for the right purpose, and things magically start to work.
Nice. So TLDR, there is AMD support. Well, not support, right? But
it works.
It works on the VIRL2 release, right? So if you were following, like I was clicking here a little bit, it actually doesn't allow installation if you have less than 4 cores. So I quickly changed this to 2 and 2, so it gives me 4. And I also enabled these CPU counters. I don't think it's needed anymore.
No,
right?
the counters is not something that you do need. So you can actually take that off. So you don't have to have that. What you need to ensure is that your CD-ROM is connected. Is that connected?
Yeah, it is connected. It should be connected. Okay. I hope so. So let me restart this. Should put me back into the installation menu? Or I will need to actually re-import OVA again?
Oh, no, that should work.
Okay. So we have this installation screen. You obviously will go through the whole EULA while I will be accepting it. Okay, and then you have to create 2 accounts. You have to create a Linux account, like a normal Linux user, and the user for the web UI. Okay, so let me go ahead and do that. So I will have Linux user will be dmfigel, and then let me put some password here. Okay. Complaints about my complexity of my password 2 times, just to make me feel miserable, I guess.
Or if it complains 2 times, then your password is really bad.
Yeah. Okay, and for the web UI, I will have admin account with some other password here, and it will complain about this again. Thank you very much. All right, and then this last piece, you just set up either DHCP or static IP address. For my specific setup, I have static, but for like this demo, I will just put DHCP. Since we have NAT, it should just work fine. I hope so.
That's it.
Okay, and we are good. We should be able to log in now, correct? So it's 64.136. So 192.168, and I already forgot 64.136, I think. Yep. And we have HTTPS here, and now we can log into the web UI here. Okay. We'll have this system health issue since this is a new installation, which you have to set up licensing, right? I will not be setting up licensing here, but that's pretty much the whole installation process. You have to accept EULA, create 2 accounts with 2 passwords, and set up networking. That's all. I remember in VIRL2 when you had to understand the different networking pieces, like there is flat, and then there is, what was else? There was like 4 different options for networking, right? And you can set up with 1 interface or with 4 interfaces.
It's 5 actually.
It's 5? Oh no. Yeah, I remember like you had to get some expert level certification specifically in that to understand all of the different options. I remember that was pretty confusing, so I'm quite happy that now it's so much easier. We have a question in the chat. I will answer it in the moment. It's around the images. So yeah, this is VIRL2 installation, very simple.
And the thing here that you can point out here is that it uses right now, by just running the controller and no virtual machine whatsoever, it uses 450 megabytes of memory, as was indicated in the statistics there. So
how much?
We tried.
Oh yeah, here.
0.45 gigabytes.
Yeah.
So that's reasonable, I think.
Yeah, compared to like 6-7 gigs, right, when we had in VIRL1. So now it's like 4,500. That's pretty amazing.
Yeah. And the thing I've always said about that is that's not just memory that's chewed up, that's also complexity in things running. So without having the footprint, you've got more memory back, which is great in a laptop to be able to run more devices. But it's also a lot less moving parts that can go wrong. So that means that, especially if you're looking at automation scenarios, having the system much more robust has been a real key focus area for us. So it's streamlined it, which is helpful for less memory usage, but also means the system itself is much more robust. Really big feature.
Yeah, agreed. Yeah, that's pretty nice memory footprint here. All right, I will kill this VM since we don't need it anymore. So let me log in here and shut this down. And I hope I didn't, no, I should be fine. I didn't kill the one that we actually are going to be using. Right, so here I have, no, not here, yep. So this is the one we will be using. So this VM has 42 gigs of RAM right now assigned, and I think it has 8 cores, if I remember correctly. Oh, I can actually check here if only I remember the command, which I don't. So I can just check here in the settings. And folks, all of this, like, so I have VIRL machine. I also have Ubuntu server, which is from, if you attended my previous streams, this is like my development machine, and I also streaming. So all of this is running on the same computer. Okay, so yeah, I have 8 vCPUs and 42 gigs. And actually, the way I like it set up to set up is that I have 2 network adapters. So I have host-only adapter to be able to connect from all of my VMs to machines behind, well, to actually the routers and switches from virtual machines outside. And I have NAT for the internet connection to actually to set up like licensing and stuff like that. So I think since we mentioned licensing, it would be a great point to ask Vern here a question. So on release, what should we expect around licensing, and how the process looks like? Less from like technical side, but like, you know, from product management perspective. So what do you need to actually get the license and the product up and running here?
Well, VIRL is sold through the Cisco Learning Store. So when someone purchases the new version of VIRL, when we get to release on it, they'll get essentially an enrollment email, and there's an interface they can log into that will show, once we implement VIRL2, it'll actually show them the ability to either download a VIRL1 license or a VIRL2 license at their option. So basically what's going to happen is they're going to download a license token that's going to point to the smart license that's been allocated for them at the CLN store, and they'll be able to use it from there.
Got it. Okay, so folks, for VIRL2 we are using smart licensing, which is a common licensing mechanism for almost all Cisco products now. So and once you set up, I think I should be able to show part of it. So once you install it, right, I think by default you have like here, you have like a register button, if I remember correctly, and you click on this register and you put your smart licensing token from your smart licensing account, and you click OK, and then you will get registered, and then there will be a license check authorized. Simon or Ralph, how do we check this license all the time? So how does it work right now?
I can probably comment on this. So smart licensing requires to talk to a smart licensing server that is, as Dimitri said, like it's a standard thing for all Cisco products, and it uses standard transports as opposed to what SALT in the previous version of the VIRL product was using. So it just uses TLS 443, like a standard TLS connection on port 443. So it's much easier to proxy and much easier to get across a firewall, for example, as Salt was using some unusual TCP ports that, and actually 2 TCP ports. So that is a lot easier now with the smart licensing solution here. Now, the actual license will be checked when you put in the license into this page. So you get this dialog where you put in your token. The token is just it's a text string, as you've probably been used to in different other products as well. And that text string is going to be sent across to the smart licensing server. The smart licensing server that will check whether you have the appropriate license in your smart account. And if that is the case, then the product is authorized, and only when it's authorized, then you can actually launch simulations. But it will also remember that authorization, so that it was successfully authorized at a specific point in time. And when you run the product within a certain time frame, within a certain amount of days, then and without connectivity back to the smart licensing server, then it will keep that information. And it will, when it can reach the smart licensing server, it will again, check back with the smart licensing server, and it will get deauthorized if it cannot talk to the smart licensing server for an extended period of time. So that's basically how it works.
Got it. So is it something like in VIRL1, like 7 days or something, or it's something different?
Yeah, it's more than 7 days. I'm not entirely sure whether it's how many days it is, but it's certainly more than 7 days. But we, it's not something that we wanted to have actually annoying to the user, or the user would have to, or like talk to that backend server every so often. And it's also something that is somewhat prescribed or defined by how smart licensing works. So we actually do not even have that much influence on this thing. So smart licensing is having some guidelines there, how smart licensing should work, basically also like how this thing should look like. So there's a lot of guidelines and restrictions or design enforcement, or like how they want to have this thing work, how they have to want this thing look. So and yeah, that's how we ended up with smart licensing. And I think it's, especially compared to how Salt worked, which is not necessarily a licensing solution, but compared to Salt licensing, this is super easy and super fast. So you just put in your token, copy, paste, hit OK, and after a couple of seconds, you're registered and off to the races.
Got it. Okay, thank you, Ralph. All right, and another question to you, Vern. So regarding licensing, if it is finalized, or if you can talk about it right now, what about different licensing options and like node limit? Because I know people are always wondering about that kind of stuff. Do you mind sharing some more details here, if you can?
Can you? I'm not sure I understand the question, Dimitri. So.
Yeah, sure. So do we still have any node limit or any stuff like that? And if you could share any more details here on like licensing, and if you have different tiers, of course, if you can talk about it.
Today we have 2 different tiers on the product. We have VIRL, which is the personal edition that you get through the CLN store, and that's again intended as a personal edition product. So it's about $200, and it's a limited to 20 nodes. If somebody wants a larger environment with a larger simulation, that's our corporate edition product. Pricing varies somewhat. The entry point, I don't want to get into list pricing, but typical entry point for that is around $7,000. And then node licensing is above that. Now there's different support levels, different feature sets that we're looking at in CML, and it's going to continue to have some differentiation over time. But that's really the two product offerings we have today. We are talking about some other tiers, like maybe a tier in between those two, but I have nothing I could specifically share on that yet. We certainly are talking about it, but don't have anything that we can announce or things like that today.
Got it. Thank you, Vernon. All right, folks. Let's Vernon, another question to you, since we already were talking about lighting and price a little bit. Release date. So, and of course, for folks, as of today, there was no public announcement. So do not expect that there will be announcement here on the stream. Doesn't make any sense. But Vernon, if you could tell us like a ballpark, and also where people can get this information, like where they should expect this to be like announced or published.
So, as soon as I can announce an actual release date, I will be releasing it via Twitter. It will show up on the CLN store page very quickly behind that, and we'll also make sure to put something up on the CML page as soon as we can. In terms of when I'm going to be doing a release date, listen, we're probably 2 to 3 weeks away. Our issues at this point are not technical. And I want to specifically, to all the work that Ralph and Simon and team have done. They've done their part. The engineering on the product is complete. Because we're doing new things like smart licensing and some other things inside Cisco, the only things holding us up now are strictly business and financial things inside Cisco about what we have to go through to do a release, and we're working through that as quickly as we can right now. So I'm in fact in a meeting right after we get off this call to try to resolve the last issues, and hopefully we'll be able to make a release announcement very soon in the next few days, I'm hoping. But we have a couple of again, I'm not going to release a date that I can't hit, and as soon as I know I've got all the final financial approvals from our Cisco's financial organization, I'll be able to put a date out there. But we're very close.
Sounds great. Yeah, folks, you heard the man. Very close. We are not talking about Vern
we're not talking months here, folks.
We are not talking months.
We're talking weeks, not months. I just can't nail down on this is the day.
Okay.
We're very close. It's just as soon as I can nail down a day, I will put it out there. The first place you'll see it'll probably be Twitter, off my Twitter, when I'll tag VIRL and the other accounts that are out there for that is when we get it out there.
Perfect. Thanks. All right, folks, let's actually go through some of the pieces of the product, some of the different features. So here is the main page, like home page of the VIRL. I already logged in. Let me actually do it again. So if you go to the IP address of VIRL, you'll get to login page. So I will just log in with my credentials, and you can see that the UI is very clean, right? There are not a lot of options that like you don't know like what to do. A lot of stuff here is pretty intuitive. We will talk about some interesting stuff in just a moment. A very quick question, and Justin, question for you here. Where is VIA Maestro?
What was the question?
Where is VIA Maestro?
There is no VIA Maestro anymore.
There is no VIA Maestro. My life is not going to be the same. All right. So we don't have like a standalone client. Is that correct, folks?
Correct. Yeah, everything is done via the web interface or via automation library.
Perfect. So we have only web UI right now. Or you can access all the stuff through API if you want to. All right, so you have here, what do you have here? Like basic CPU, memory, and disk stats. As I told you before, all of the images, all of the images are bundled in ISO that you mount separately as a like CD drive, and I can't find it right now, but you actually see me do that versus removable device. So I have this CD here set up, and it has this ref plot. I think it's like what 6 gigs right now or something, and it contains different images. So let's go ahead and like create some lab. So I will click here on add lab since it seems reasonable. I will put some stream, for example, here, and then I click on it. Yep, and I go to the to the lab page basically. I remember in VIRL2 you had this design and like simulation thing in VM Maestro. Justin, do you mind telling us more about like what happened with those things, with those different like design and simulation, and like how this UI is working and what are its different pieces?
So as far as the interface here, I guess the concept with VM Maestro was you would design a simulation and then launch the simulation. With VIRL2, everything is done through the web UI or via an automation library via the API, and it is all done in real time. So once you add nodes to the canvas and you start them, you can still interact with that same lab without needing to stop and start it again. So if you have 2 nodes on the canvas, you start those nodes, you can then add links between those nodes. You can delete a link between running nodes.
Okay, cool. Do you want to talk also a little bit about the technology stack that is used for the UI?
So I think, Dimitri, one thing, I'm not sure if you're going to cover this or if you have any plans to cover this, but I think it's important to mention this at this point, that we had in mind kind of a lab analogy and like something that comes close to like a physical lab, how you would do physical labs, and kind of model this within the VIRL product or within the network simulation platform here. Is that something that you had in mind, like persistence and these kind of things? Is that something that you wanted to talk about like later on, or is that a good place or a good point in time to actually talk about this right now?
We can talk about this right now. I didn't really have that in mind.
Okay. Yeah, so I guess it's important to mention that, and it kind of goes into this thing about like design mode and simulation mode that was a thing within VM Maestro in the previous product. So we looked at this and thought, okay, that doesn't really make a lot of sense, that you have to have something that where you strictly design things and then you push it to the server, and then you are in simulation mode, and then if you want to design something again, then you would have to stop it and bring it back into design mode, etc., etc. So that just didn't click for us. So we wanted to have something that becomes more like a real lab would behave, where let's say you have some physical rack space, you put in stuff into that rack, you cable it, you configure it, you power it on, you configure it, and then maybe you power it down and you work on a different rack or in a different lab in that nomenclature, and then at some point you might power down the second one and go back to the first one, but you would expect the first one to be exactly in the same state as you have left it when you stopped it, right? So we wanted to have, bottom line, we wanted to have a lab as a persistent experience. So if you create something here in your UI here and drag nodes onto the canvas, and you configure those guys and and you maybe installing software or maybe installing a license into one of these machines. Like, let's say like a CSR is a perfect example. Like the CSR can use a real license, and again would use smart licensing, so it needs to talk to the smart licensing server. But when it talks to the smart licensing server, it will tell the smart licensing server about some properties of the virtual hardware in this case, and say, hey, I'm this and this machine, I have this and this whatever ID. And when you apply the license, then you expect that license to stay the same. In the previous product, it was the case that every time you started and stopped the lab, that machine was basically destroyed. And by destroying the machine, it would lose the capability of applying that license, because that license was tied to that specific machine. And by starting and stopping the thing, it was destroyed. And when you started again, the license would not apply anymore. So we wanted to have that much more in a way that reflects an actual physical lab. And that is where we ended up with this. So where you have the ability to design something, to start something, to stop something, and it will just behave like a physical device. You are able to add devices into a running topology. You are able to rewire things while it is running. So even when a VM is running, you can actually remove a link from a VM and move that link to a different VM, and it will all be handled on the fly dynamically underneath. So it comes much closer to what you would expect from a lab, what it does in a physical environment, here in a virtual environment using VIRL as a platform. So that's, I think, like some of the thoughts that we had when designing the thing and when building the architecture here.
Awesome. I have a couple of questions here for you, Ralph. So just to double check, we do support hot plug, right, of the ports. So
Yeah.
you can replug on the live device, correct? You don't have to stop and start anything.
That's right. What we do not support is we cannot at this point in time. It's not entirely impossible, but we haven't done this so far. Hard adding of interfaces into running devices. So, excuse me. So what that means is that you can rewire stuff, but you can only rewire stuff into existing interfaces. So let's say if you add a new device to the topology while the topology is already running, and you want to hook up that device into a switch or something on your topology, then that switch has to have a free port. So you cannot say, oh, I have like 4 used ports on this machine, and I don't have a free port, like no spare port. So I cannot add another port into such a virtual machine while the machine is running. So that is a kind of a restriction, but not really. I mean, that's pretty much the same thing as in the real world too. So you would have to power down the thing. And in our case, you actually have to you have to power down and kind of clean up that machine wipe, as we call it, and then you can change the hardware, like add more ports, and then bring it up again, and then you can add more stuff to it.
Got it. All right, Ralph. Another question: why don't you and I go through this list of nodes, because it was also one of the questions in chat. What images will be included with the first release? So let's go through every one of those together one by one, and briefly talk about it, like very briefly. So what is external connector?
Yeah, the external connector is what it does, or what it says. It's a connector that connects to something external. So in other words, we wanted, as you alluded to in the beginning, or like earlier on, the previous product had these 5 different connectors or interface requirements for connecting the VIRL host to the external world, and most of those were, let's say, some sort of a leftover, not a leftover, but depending on how OpenStack does things, right? So flat and SNAT and these kind of things, they are OpenStack terms. So we wanted to have connectivity, external connectivity in VIRL2 very simple. And the way it is being done right now is you have a single network interface card that goes into the VIRL2 server. That network interface card is used for management. So basically, when you go to this UI, you attach or you connect to that network interface card or an IP that is bound to that network interface card. but we also use that very same network interface card for external connectivity. So that external connector that you now have on your screen, that can be configured. And right now in this release, there is 3 options basically, and like 2 very obvious options and 1 custom option. And the 2 obvious options are, I can put this thing into network address translation mode. And when I put it into network address translation mode, then everything that is connecting to that external connector from within your virtual network here will be network address translated to that IP address that is bound to the VIRL host itself. So if your whatever thing here, VIRL controller.virl.lab is 1.2.3.4, then a VM like a CSR or something that is inside of your VIRL simulation here connecting to that external connector will hide behind 1.2.3.4, okay? And if you put that thing into bridge mode, then basically the external connector will be in parallel, or like will use the same network interface card. And if you run DHCP on your network that your VIRL host is connected to, then your CSR, for example, would pick up an IP from your DHCP server, and it might be like 1.2.3.5 instead of 4. 4 is your VIRL controller, and then 1.2.3.5 would be your CSR, because it's just like, it uses the same network interface card. It's just a bridge, and that reaches out, through the same thing. So that makes it very easy to do the external connectivity. And the custom one is something that we've added later on, because there are some requirements where people want to have, okay, I have my management network, which is where the VIRL host exposes its IP and its management interface, et cetera, et cetera. But they want to have their network devices in their simulation, let's say, to connect it to a lab network that has, physical devices, for example, and they should be separated. So you can create a custom bridge, which is not very comfortable at this point in time, but for advanced users and for that particular use case, you can do this. It requires a bit of Linux plumbing. So that is in particular an area that we want to improve in the future. So this is something that is very high up on our roadmap, that we want to expand on this entire thing, how we do the external connectivity. It still will be this single network interface does it all for the very simple use case, but we want to expand on this and say, okay, we want to have an external network connectivity editor in a way where you could say, okay, I have now network interface card 2 and 3 in my box, and I want to have them configured in a particular way and be able to select where this external connector connects to. Right now, it's just very simple, and it does the job.
Got it. Thank you, Ralph. So I guess just to summarize, by very easy way to do external connectivity is to select either NAT or bridge, right? So with NAT you get an IP address on your, you kind of like do path, right, on the and you will get the IP address on your management interface, and with bridge you kind of you will be on the same network, and then you can do whatever you want, more or less, right?
Right. They're then peers, right? So there are peers from the outside. You will see 2 IP addresses coming from the same box with 2 different MAC addresses, 2 different IPs.
Yep. So the reason I kind of bring this up is that remember, folks, I have this another VM. This is my Ubuntu server, and so what I have is that on my VIRL server, I have my main interface is host-only network, and then my second interface is NAT for smart lighting. And then for that first interface, this is the one that is going to be used by VIRL. I will be able, by selecting a bridge here and putting an IP address in this network, right, on the networking device, I will be able to connect to them from my VM, which is outside. So this is why I'm selecting bridge. And then if you want to customize all of this, you can create Linux bridge, but then you have to go to the shell at least today. Correct, Ralph?
That is absolutely correct. So that's the reason why we call it custom. it's something that needs the user actually needs to create that bridge manually at this point in time, and that is something that I would consider an advanced use. But as I said, we want to make that much more user friendly in a future release.
Got it. Okay. So let's go next. So what is the server?
Server is just this is the smallest node type that we do have in there, like in terms of a full virtual machine. This is a Linux host that or Linux VM that just uses 96 megabytes of memory, and it's tiny core Linux. I think I haven't seen anything that goes smaller than this in terms of a full virtual machine.
Okay. You can. And by the way, what is this edit config on the Linux machines?
It's basically day zero configuration for all of these guys, and on the Linux machines, especially on these guys. I mean, there's Ubuntu, which is also Linux, obviously, but that uses Cloud Init. But if you don't have the ability to use Cloud Init, like this tiny core Linux does, then whatever you put into that configuration is just it's just sourced into a shell, into a root shell actually. So whatever you put in there, it's just executed. So if you put in there rm -rf / or something, then yeah, you get what you pay for.
Okay, cool. And Alpine, is that a Docker container, or it's just
no? Those are all virtual machines. So the Alpine VM it's larger than the server VM. The server VM, which is a tiny core one. But Alpine has it's a bit of a Swiss Army knife, so it has like different tools like RouteM or iPerf or T-Shark or TCP dump. Like it has a bit of a tool chain that you can use if you want to have a ping target or use a bit more advanced networking things. Like iPerf is a good example there. So that is all built into the Alpine container. There is another one that is the desktop one, which is also based on Alpine, but that actually runs a full X11, like an LXDE desktop, I think, where you do have Firefox and Wireshark and other desktop tools that you can use in there. And they are using a bit more memory. So the Alpine one, I think, uses 512 megabytes of memory, and the desktop one uses a gig, if I remember correct. So because it does more, like you can run Firefox in there, which is pretty decent.
Okay.
These other guys like T-Rex. T-Rex is the traffic generator from Cisco. So we have moved away from Ostinato as a third-party traffic generator because we have this thing in-house, which is T-Rex, right? And T-Rex is pretty decent in terms of traffic generation. It is a client-server model, like Ostinato is in a way. So the thing that you have there, that T-Rex node that has two interfaces, and that's just like the piece that actually generates the packets. And you need to have a client, and the client is something that you do have to install separately on your machine. That's a Java application for what it's worth. But that thing is a GUI where you can synthesize packet streams and traffic patterns, and it's pretty powerful. So it's actually quite interesting. The next one is the WAN emulator. That's it's just a bump in the wire. So it's basically a bridge that you splice into a link, and you can dial in some sort of a user interface. You can dial in latency, jitter, loss, and bandwidth, and it does a pretty good job of applying these things. So we have some profiles in there where you could say, okay, give me a satellite link, or give me a bad Wi-Fi connection, or like a WAN link or something like this. So there's like a dozen or so profiles built into it that allow you to dial in some kind of typical traffic or link condition on a specific link.
Okay, so just to clarify here, you interact with it like via the console or something? Is
that's
that correct?
Right.
Yeah.
Yeah.
Okay,
that's
so
right.
so you put it, you plug one port, and then you plug another port right to it. So it's kind of like on the wire, and then you configure it, and then you can set up properties of your link, like delay, right, and packet loss, stuff like that. Correct?
Correct. So that was one of the things that we discussed. So we could have done something where we hide it basically. So you right click on a link, for example, or you click on a link and you say, okay, I want to have specific properties for that link, and then if you dial in specific properties, we could have done that in the background to splice that VM in and do that stuff behind the scenes. But we wanted to have less magic in the product and be more explicit. And if you have that thing in your topology, okay, so there is WAN emulation or link conditioning happening between this VM and this VM. So it's very obvious. We still do have the option to make that more transparent, to do that behind the scenes. But we try to stick to the, do things explicit and don't apply any magic. So this is very explicit. It's a bump in the wire that you actually do see in the topology. If you see this thing, okay, then this link is being modified, link conditioned.
Got it. Okay, let's address a couple of questions in the chat before we continue. Any option for running it in bare metal? And Ralph, I think it's also for you.
To run what? To run the thing in bare metal?
To run VIRL in bare metal.
Yeah, it's something that we do not support out of the door, and simply for not from a technology point of view, from a technical point of view, it's more from a support point of view. We do have internal people that run it as bare metal, or on bare metal. What we built is basically a 70 megabyte or something RPM that runs on top of CentOS. So you can install this on bare metal. It's a matter of how do we support it, how do we structure support around this. So it's something that we certainly do plan for the future to be officially supported, but right now it's not. Right now this is an OVA form factor, but technically there is no reason why it doesn't work on bare metal.
Got it. Another one is it able to import appliances like FMC, ICE, and I will add here anything else, including third-party vendors?
Yes and no. So we explicitly have something on our table right now where we need to extend the node schema to be more universal, because there are certain VMs that require some changes to the node schema, both internal as well as external VMs or third-party VMs. So we want to be able to run everything that is running on top of x86. Yeah, so there are some things that we already do know that work, like firepower stuff does work, or the entire SD-WAN. We have made some changes to the schema to support SD-WAN, vManage, and vEdge, and all these other things, and even like the IOSXE, what is it called? Like the IOSXE based vEdge thing. So all of these things do work. There are certain things which we realize that we do have to extend the node model, but that's certainly something that we want to do in the future. And I would think that most of the stuff already does work, especially if you take that persistence into account, where you keep your virtual machine, like ICE, for example, or like vManage. If these guys need to initialize a database, for example, then you or you might need to apply a license, a demo, even if it's just a demo license. Then you do want to ensure that your VM, even if you stop it, keeps the disk and keeps its memory, basically. Not memory in the sense of DRAM, but in the sense of the disk that it stores its configuration on.
Got it. But can you actually add some of these things that actually work but are not listed here yourself today?
Yeah. So that is built into the product already. So we do have this concept that, as I said, we have this node schema that defines what a node like that is on this palette on the right side, what that looks like. And you can go to the lab manager and then go into the node definition in the menu. And that will show you that node definition editor. So we have image and node definitions. So there is a list of images and a list of node definitions that they build a pair basically. So you have a node definition, and the node definition is associated with an image definition. So you can have, like, if you look at, and right now this is just a one-to-one at this point in time. So all of these nodes, they have just exactly one image, but there is nothing that prevents you from, let's say, okay, I download a newer ASAV version, I should say, and then import that ASAV version, and then it will get associated with the ASA node definition. And then you can choose, if you drag a ASA node onto your canvas, you can choose which image is actually going to use. So we ship with a specific version, I don't know what it is, 9.8 or something. And then you might be able to download 9.9. You import that 9.9 image into the product, and then you can use that with the 9.9 version.
So you can definitely use the form here that you're using, Dimitri, but it's also all the definitions are YAML files. So if you were to download one, you could use that as kind of a base and then modify it.
Oh, so I can import here, correct? No, it's actually...
Yeah, you can import a node definition.
Yeah, okay.
And guys, one of the things to stay tuned on is, now that we're getting 2.0 out the door, one of the things you're going to enjoy is that you're never going to have to wait many months or years to a next release. We are going to be on a much quicker release schedule going forward. And one of the things that's on our initiative list is to really broaden out the catalog of Cisco devices that we make available out of the box. And that's clearly something in the next 3, 6, 9 months you'll see dramatic improvement on as we move things forward. So obviously our focus was get this out the door so that we could get the new platform out to you guys. Now, beyond features in the product, one of our shifts and focus is very much on make sure that you guys get as broad and deep a list of platform availability going forward.
Thank you, Vern. So do I understand correctly that the plan is to have some kind of central repository where you could basically import anything that, is in that repository, and the plan is to have as many Cisco stuff as possible?
That's the idea. That we don't have a final design yet, but that's, in principle, that's the idea we're working toward, yes.
Got it. Okay, very cool. All right. So let's go back to the notes. I will cover some of the rest ones. I mean, they are pretty self-explanatory. Like unmanaged switch is something also you can find in VIRL2 and other platforms. It's just, it switches many ports, especially useful with like when you want to connect to cloud, right? You have only a single link on the cloud. So, but you want to connect multiple devices, so you'll use something like this. And then you have ISV layer 2. Do we actually have we no longer have VIRL3? I thought we had it, no? Oh, we have it right here.
There.
Yeah, I'm sorry, I'm blind today. Okay, so we have ISL2 and ISVL3. We have Nexus, and we have newer Nexus 9K. We have ISAV, CSRV running ISXC, and we have XRV and XRV 9K. So one common question that I got, and it was not in the chat, was around things like SD-WAN. So I know that vManage and vEdges are not here on the list. Is this something planned? And also, if you have access to those images, can you do it today with existing functionality?
Yeah, it's something that we do use internally already. So like a lot of people are using SD-WAN images internally. This is not a technical question. I mean, especially for the SD-WAN things, it's not a technical question. It might be for other platforms where we let's say we use more disks that we currently have support for, or have very specific VM settings that we haven't, that those platforms that we are currently dealing with require. So there might be some things in that department, but specifically for SD-WAN, all of that works already. It's just a matter of, whether we can ship with this or not. So I'm currently of the opinion that we can certainly ship with all these node definitions, which is this YAML data structure that says this is how this SD-WAN thing looks like, and it requires a disk, but we don't ship the disk because we are not allowed to ship the disk. But if you will go to CCO, or like if we have in the future this portal that allows you to say, okay, I'm entitled to download this SD-WAN thing, and then you can certainly use it. So it's not specifically for the SD-WAN thing, it's not a technical restriction. It's more like, okay, what can we as the VIRL team, not as the business unit that does SD-WAN, but we as the VIRL team bundle with this product and ship with this product.
Got it. Thank you, Ralph. Let's go over some other. Yeah, go ahead.
And that was part of my comment earlier about building out the depth. Now that we've got the platform out there, we're working with the business units to, both, create as broad a list of platforms that they allow us to ship, as well as a depth in platform versions. So that's something we're going to be working on. And again, Cisco's a big company. It might take us a few months to get through them, but we'll get there.
Awesome. Let's go through over some other questions in the chat. There was a question about Asta, and actually, I have never, even though I have been working at Cisco for 5 years, I have never heard about Asta.
What is that?
Another traffic generator, Asta. I'm not sure how to pronounce it. Since T-Rex is added here, but not Asta, it seems to be newer tool to generate traffic. Do you know anything about that tool? Because I have never heard about it before.
No, I don't. How is it spelled?
AASTHA.
Never heard of it.
Okay. If some other folks on the call heard about it, please do let me know. Sorry, chat. Unfortunately, we are not aware. Will those images be available with VIRL license? So, is my understanding correct that with the license that you get on release, right? You get the ISO with all of these images here. Is my understanding here correct?
Yeah, that's the plan. That's the plan, and this is not different. I mean, apart from the, let's say not orchestration, like the images that do provide some sort of virtual functions, like the WAN emulation thing or the T-Rex thing. The other images in there, like Ubuntu, CoreOS, Alpine, etc., they are open source Linux images. And the other images like IOSV, IOSVL2, Nexus, XRV, ASA, CSR, they are all already bundled with VIRL1.x. So there is no change at this point in time in terms of what kind of images are shipping with the product.
Got it. Okay. But also, just so you know, folks, for example, something like CSR 1000V, right? It, if you like install it, I think you get like 1 megabit per second throughput with all of the features. If you want like 100, some other throughput, right? Like 100 megabit per second or higher, you actually need a smart license specifically for that. So all of these images that you see are bundled as of today, but some of these images may also require additional entitlement for either features on them or throughput or something like that. Right. I think it would be a good point. Let me see if we missed something. There is a question about port channel support on specific image. Unfortunately, we can't answer that because we are not building the reference images. So if the reference image has support for some specific feature, then yes, it's supported. If it doesn't, then it doesn't. Unfortunately, we are not the ones who are actually creating these virtual images. There's an interesting question about Terraform. Is there a Terraform provider for VIRL2?
No, but that's certainly something that so one of the guys we were working with, he's working with HashiCorp, and he volunteered. so I'm going to hold him accountable for that one. So we are going to have a Terraform provider. We do have an Ansible plugin, so you can write Ansible playbooks to drive the life cycle of a viral simulation. So that is already existing.
Got it. And is the name of that person Kevin?
Is that person on the call? So if he's on the call, he's certainly...
No, not on the call, but if this is Kevin.
Yes, that guy.
Okay. Sounds exactly like Kevin. All right. What about support for other features, specifically data plane and node control plane? Again, folks, those type of questions are not for VIRL team. Those are for engineering who is creating the reference platform. So for example, if ISXR v9K supports data plane on its image, then technically it should be supported in VIRL. And Ralph, correct me here if I'm wrong.
No. I mean that's exactly right. I mean we are basically a conduit, or like, you know, if you buy the product, if you run the product, then we certainly are more than happy to take all these things and try to talk to the business units and get their attention. It's a bit of a chicken and egg problem. If we have 1 million customers and all 1 million customers are going to ask for a specific feature in a specific product, then I guess the BU is willing to listen, right? So
we are strengthening those relationships, and I think it's a bit like what Ben was talking about with the download portal. We are increasing that, so we can't promise any specific features like port channel or something that comes up, but we're strengthening that a lot more at the moment. So hopefully that will start to really yield some more feature sets coming. So it's looking like that's increasing velocity there, which would be nice.
Yeah.
Dimitri, we should actually get...
sorry. No, we finally have the right people in the right places to really pursue that a lot more aggressively than we have in the past. And again, we'll be seeing a lot of, hopefully, some positive news on that over the next quarter or two.
Yeah, folks, and it's also about, like Ralph said, it's also about demand, right? So if there are many people using VIRL and asking where is that or where is this, then it's so much easier to go back to engineering and say this is what customers want. So all right, I think we addressed majority of the questions in the chat. So if I missed something,
let's get something started, Dimitri. I mean,
exactly. I wanted to do exactly that. So, and you know, to make sure I flex on my very powerful machine, I will just put a lot of routers as well. So, okay. So, and of course, I need external connectivity because the test succeeds only when I can use network programmability features from outside. This is like my benchmark, you know. Okay, so let's just, you know, put CSRs, and unfortunately, folks, I'm mostly familiar with CSRs. Can you actually put multiple nodes at the same time, or you cannot do it right now? Like
you can clone a node by using that button at the bottom left. So if you put specific things in there, so it will clone it.
It has very interesting name here. Okay, so I have what, 5, and then 2 more. Let's do 2 more.
It clones the node, so it also clones basically the name of the node.
Okay, and we will connect. Well, let's connect everything here. How many ports does this switch have? Does it have enough?
By default, it does have 8, but it adds more if it's not like if it's not started yet. You can add more.
Oh, okay. So let's go ahead and
automatically adds more. Connect them up, and
this is something that I barely see. And so, folks, for our older VIRL2 releases, this NOT connection was slightly different. So yeah, now it has this interesting pop-up menu. I think this is Justin what you built, correct? So
Correct. Yeah.
yeah, you just click on it and you drag to your node and you select the ports. So let's connect all of these devices. Okay, once I do it 2 times, I already want to like write some kind of script to do it for me.
Well, you could hit the use next
next
available. Exactly.
Yeah.
Okay.
So that's slightly more efficient.
I do need to make sure though that I'm using gig1 everywhere.
Always. And that's another thing here, while you're connecting these things. We wanted to, it's like in VIRL1, there was this out-of-band management notion where the first network interface on each device was kind of taken away silently from the user to do this out-of-band management thing, which was sometimes really, causing some headache or, what is going on here in a magic way. And we have removed this. So this is not part of VIRL anymore. So you do not lose your first interface. If you want to do something like out of band, you can certainly model this, but it's not done automatically and like behind the scenes in a way.
Okay. So I added 10 nodes here. I connected all of their management to the switch and I connected these two. There is another very, very interesting stuff. So, and while I will be building config for that, so if you could talk about it, either Simon or Justin or whoever designed it. So the edit config thing, right? So we are talking here about, well, VMs, right? So I'm very curious about like how do you load this config in the first place. So while I'll be building that, if you could talk about this briefly, that would be awesome.
Yes, Sam, you want to probably talk about this, don't you? Throwing you on the bus.
No, you know the low-level stuff. You can do a more succinct explanation than me.
Oh my God! Yeah. So you're like the high-flying guy. Okay, I understand. Yeah, so the idea here really is to provision day zero configurations into devices, and the way this is being done is different per device. On routing devices, it's typically using a specific way of provisioning a day zero configuration by having a disk or an ISO, or typically it's a disk or an ISO file that is attached to the virtual machine. It has a specific file name on it, and then it loads. The device comes up, it sees, oh, I have this thing attached, and there is a specific file name on it, and then it sources. And it doesn't source it, but it loads that configuration into its running configuration. Yeah, that's it. So for servers, I said that before, it's usually just a very crude mechanic of sourcing that script, basically shell commands. And for switches and routers, it's what the device supports, iOS configuration or ASA configuration, whatnot. So yeah, that's basically it.
So we are creating ISO from that config that you put there, right? And then we load
it. Depends on the device, yeah.
Mm.
Typically, it's an ISO or a disk file. For some of these guys, it's actually a FAT formatted disk. Like iOS, I think, does use FAT formatted MS-DOS FAT formatted disks. The CSR uses an ISO file or an ISO image that is attached to the VM.
Got it. Okay. Now, another thing, while I will be also applying this, if you could talk about the lab portability. So how do you make the lab portable? How, like, you export it? What is contained there? And I think it's really important because I will give some background here. For example, I've been using Genet 3 for a while, right? Where you export the lab, they kind of package the, I think like the disk or something for the VMs, and well, it's quite, the resulting project is quite big. And then you kind of like import it, but you have to like make sure that all of your nodes are the same or something like this. It's kind of tricky. So if you could talk about lab portability and export thing, I would really appreciate it.
Yes, Simon, do you want to talk about this?
Yeah.
Lab
Simon.
portability. Yeah. So the format is all YAML. I think I'm answering the question right. So you can just download it under the menu at the top there, or through the REST API. You can download the lab, and that's now just a YAML file. So we've tried to keep it simple and modern, moved away from the XML previously. If you did have a VIRL topology from version 1, you've created in Maestro, then you can import that in the lab manager on the previous screen, and again that's through the REST API as well. But essentially everything's YAML based, all the definitions that we saw before, and also for the topology. And we do have the option to extract configurations in the above the edit window that we've got, or that Dimitri's typing in now. It's a grayed out button because we don't have a lab running. But once it's running, you can extract the configuration, which is like the workflow back in VIRL 1. Where it will log into the device and show rather than scrape that config. So using pyATS to power that bit there. And then you can use that to scrape the configs back to the lab on the server, and then download that file and then use that to share with other people, or to push into version control. So lots of people ask about Git integration and things like that. It's something we are looking into to figure out how to get that workflow working right. But the key thing is at the moment you can download that YAML file and use it in whatever format like that. So, you know, there's an option today, and we want to streamline that. And that goes to many aspects of the product that's come up in different aspects of this call. Is trying to streamline those workflows. But yeah, you can download it as a YAML file.
Do you package disks as well for VMs, or you actually put in that YAML file this startup configs?
It's just a startup config at the moment, yeah. We might go further in the future, I'm not sure, because it is essentially the differential disk that lives on the server. So when you shut down the device, we do persist the config, as Ralph talked about before, with all the licensing and MAC addresses and everything that's used for the UUID. So that will sit on the server. It might be possible for us to do some stuff around that with snapshotting, either to make that available as like a template to use for other devices, or to have something like a history, so you can look at snapshots of that single device, or perhaps to download that as well. So some things you won't be able to always grab everything in the running config. Some other things might be persisted. So I don't know. We don't have any concrete roadmap feature plans for that sort of aspect, but there's definitely some technical possibilities there we can explore further.
Yeah, we talked about this in the past, so there are some ideas around this, and you know, just tossing out one, we could base 64 encode the disk content and store it in the YAML file. Would that work? I'm just kidding. No one got
that. We could have a YAML file, a YAML file plus the differential images like a table or some kind of archive format.
Yeah, I was making a joke, Sam, and I thought that we could make like the disk files in base 64 and code that as a string and then put them into the YAML file directly.
So do I understand correctly that resulting lab YAML files are actually really small right now, because we actually put just, you know, config as a text string there? So
they are.
Okay.
Yeah.
So, and this is, folks, I think it's very great benefit of something like VIRL, right? Because you have a lot of these images bundled as well, and you have this feature where it tries to deal with the configs as well, like in almost plain text, like extracting them and loading them as well. So what it results in very easy process of sharing this lab, right? You just share this very small YAML file and then you have your lab. And this is something I also really liked in VIRL2, where there were all this, like there was like Git integration. You could easily download this viral file, put it on any server you want, right? And just click run, and then you have your lab exactly the same like it was on different servers. So you also have this benefit here, right? You don't have to care about how do I get an image, how do I upload it, how I rename it in some product I don't want to name on the stream right now, and all of these other pieces, right? Like you just take lab that someone else built in YAML format, you upload it, and you don't have to care about like how do I put these images here. You just start it and then there you have it. There are a couple of questions in the chat. Let me see. Will it be possible to use PCI pass-through is to add Wi-Fi NIC to a desktop? Really interesting question.
Can you repeat the question?
Yep. Will it be possible to use PCI pass-through to add something like Wi-Fi NIC to a desktop?
That's an interesting question. Technically, I don't see a reason why it should not work. That's something that KVM already can do. It's nothing that we have planned. Maybe something for the roadmap to at least investigate whether this is something that we want to do or not.
Okay, cool. Another question for Vern. Are there plans to have VIRL2 personal license to be able to host unlimited nodes? 20 is too low. I need 20,000. Wow.
Okay.
Yeah, that I think you need to buy CML then. And yeah, no, we're not at those numbers yet, obviously.
Okay, cool. I don't think... Oh, there is another one that I almost missed. Do you have any plans to integrate VIRL2 with NetSim?
What is NetSim?
Didn't we have NetSim in VIRL2? Like there was some...
I mean, there is NetSim, AS NetSim within Cisco, but there is nothing that is externally available. That is, as far as I know, that's an internal service that is offered for advanced services inside of Cisco. Is that a question?
I don't know. Chat, if you could provide us more details around your question, that would be awesome. All right, I have this topology. I have my startup config, so let's start it. And there is a reason
why... You still didn't start it, man.
No, but there is a reason I put so many, and I didn't want to start because I wanted to show this. I think this is also pretty cool. So if I go to simulate and I start this lab, and then I go to nodes, yep. So something I really like, and I can appreciate the design here. So why some of these nodes are cute, Simon?
Yes. Yeah, so basically what we've tried to do is in VIRL2, if you threw a lot of, your laptop might be able to run a lot of IOSBs, or you've got a server, UCS or whatever that's running some of the large virtual machines. It might be capable of running them all, but most of these machines have a pretty hefty startup cost. Once they settle down, they finish booting, they settle down to a much lower CPU and RAM and disk usage. But when they're booting up, they use quite a bit. So what we're doing here, and yeah, we can definitely see that in the server load that we're maxing out the server. And what we've got here is quite a few CSRs, which use quite a bit of resources to start up. And so essentially what we're doing is we're looking at the requirements of each of the devices, which is what we specified back in that node definition that we talked about earlier to import we want to import a third-party VM. One of the things we need to specify is how much RAM and vCPU that device needs so we can allocate it. We look at that information and then look at what's being hit with launch. So in this case, Dimitri hit launch and we want to do a server, an external connector, unmanaged switch, and then a whole heap of routers. So we'll look at the requirements of what he said to launch, look at what's available on the system, which is essentially that the CPU load of the server and the RAM load that was on the start page. And then we'll stagger the launches so that we don't overload the system. So what we see is they all went into queue initially, and then depending on how big the devices are and how big the server we're running it on is, we will then launch maybe one at a time, two at a time. Usually it's more like 4 to 6 at a time. And then once each device has booted and settled down, then we will see that the server load's dropped a bit and we can launch another one. And so what we'll see is 4 or 6 at a time to start with, and then as we approach the load of the system, that will start to slow down. We might just launch one at a time to really get to the maximum. So we've set it at a relatively conservative threshold, which for some people might be a bit too conservative in version 2.0, where it will go to 80% of the server load, because we prefer to start the VMs without overloading the system rather than pushing it beyond its limits. But what we will do in future versions is to tweak that algorithm and allow it to run a lot closer to the capacity of the system. So it's perhaps a little bit conservative now, but we err on the side of reliability. This is quite handy if you're doing the user interface like Dimitri is here, but this is especially helpful if you're doing an automation scenario. So you can script all this up and have your lab of 10, 20, 30 devices and say that I want to boot this lab up, and then it will reliably start that up. Whereas in version 1, if you launched all these at once, they would all have very high resource contention, and some of them would end up in a broken state, and that's really not good for automation. It's annoying if you're doing it through the UI, but if you're doing an automated scenario using Terraform or Ansible or whatever plugin, you really want the nodes to boot up reliably. And then the other thing we can see here is that some of these are in booted and some of these are in started. And so what we're doing as part of, again, this concept of ease of use and to make it usable for programmability is that we'll monitor the console of the of each of these devices, and we'll get Ralph to talk about the console multiplexing in a second. But essentially what we're doing is watching the console as each of these devices boot up. And when we see a message such as press enter to begin, or would you like to apply the default config, or whatever it is depending on the virtual machine, we then know that that device is finished booting. Because just because we've launched a device to start simulating doesn't mean it's available. Some of them might take 30 seconds, 60 seconds. Some of them might even take 10, 15 minutes if we're launching an SD-WAN device or an XRV9K. So what we do is look at when it's finished booting and then provide that booting string, which again, so now we can see that router 1 and router 2 have now gone to booted because they took a few minutes to boot up. So here's about 4 minutes. And so the aim again is to give the indication to the user that this device is ready to interact with on the console or using a script. And then you could write a Python script essentially that spins up a big one. It staggers the launches so they're reliable, and then we'll monitor each of those, and you can track it until the lab's booted. And then when the lab's booted, so you just have like a for loop or something pausing it. Once the lab's actually booted, then you can start running the script. So that can all be automatic and very reliable and easy to use. That you're not trying to ping the devices or scrape the configs to see if it's ready to go. So all that integrated out the box is one of the things that makes it quite nice as an end user in the UI, but really, really powerful as a CI/CD or automated workflow.
Awesome. Yeah, folks, for those of you who follow my streams, we recently were trying to build 500 node lab in Nginx 3, and if you remember me doing that programmatically, right, I had to set up this stagger mechanism myself in my code, right? I couldn't just start 500 nodes at the same time. So like I had to stagger it, and in VIRL2 all of this is built in, right? And this is even more important for machines where you have like where you don't have unlimited resources, right? Like I also remember some of the VIRL1 simulation where technically you could run that, like 10 nodes or on the servers that I had, but you couldn't start them all at once. and if you do, like OpenStack like will crash or something, like something weird will happen. Now here you can see that with this stagger mechanism, it's really important for those use cases where you either doing it automatically or where you have resource constraints and you like technically can start all of them at the same time. All right, so while we were talking, you can see that all of the nodes were booted and you can see this green check mark, right? So this is when the VIRL2 recognizes that that node is fully booted. So it took what? I think it took like around 5 minutes, 5 minutes-ish. This uptime is keep running, so like I kind of lost the moment. But you can see that all of these 10 nodes here is a green check mark. So Ralph, I think this would be a great segue to talk about consoles and like how do we actually do this green check mark and console multiplexing. So do you mind elaborating on that? Did you lose Ralph?
No, I was muted. Yeah, sure. So one of the things that we wanted to have in the product, one of the design philosophies here is that we want to offer different ways to do the same thing. Like in this case, multiplexing, console access. So one way to access the console, as you've seen Dimitri demonstrating, is to go into the web UI and then access the console right from the web UI. But there is also different ways to use the console outside of the box, where you want to use, let's say, a native application, let's say iTerm or secure CRT or some of these things, right? And then also having some sort of a terminal server. And all of these different ways to access a console inside of the product is going through a console multiplexing facility. And that service, that facility that allows us to access consoles from different places using different mechanisms and actually, have two windows or multiple windows open to the same console, even though that it's actually a console, which is, it's one user, one console, but by using that multiplex mechanism in between, we can have that console and other things as well. So it's not restricted to consoles. It's also possible for VNC, like the VGA screen basically of a server. So if you have like a graphical user interface, a desktop or something on a machine, then you could use VNC access to access that screen, and that's also multiplexed. And the same goes for packet captures. So these are also multiplexed using that multiplex facility in there. So yeah, so we wanted to have a way to make those devices, consoles, VNC screens, packet captures, available via a multiplex facility, and to offer the user a way to consume these different devices in different ways depending on what the use case is. So like the simplest use case is using the UI. Click on the device, click on console, have an XTerm or like a terminal application built right into your web browser to interact with the device. But then there's also ways to use native applications. And it's important that all of these things, everything is using that API, as we mentioned in the beginning. And also everything is authenticated and everything is also encrypted going to the server. So we also put a lot of effort into making this thing secure. And that was part of the experience releasing a product within Cisco, is that there is a ton of stuff that is related to security. So all the boxes that you need to tick to get a product out of the door. And we, based on how we designed the product, we had actually not that many problems to get those boxes ticked, because as I said, we paid a lot of attention, or we hope that we did pay a lot of attention to all of the security aspects of the thing, exposing only a minimal set of ports that are actually open to the outside world, which is like 443, obviously, to access this thing on TLS and SSH, which is accessing the terminal server. And then there is only the last port that is open onto on the box is port 9090, which is also authenticated and encrypted, which does the low-level system administration stuff using Cockpit as the tool of choice here that was built into the operating system and offers us the ability to administer underlying base operating system tasks. So yeah, that's basically the long-winded story there, while Dimitri is doing busy work.
Yeah, thank you, Ralph. Yeah, so and I have an interesting question, but before that, one thing that I did while Ralph was talking, I have this 10 CSR topology that I use in a lot of my presentations. It's not exactly the same like how you see on the screen, but it also uses 10 CSRs. And one script that I have is called RESTconf check. So RESTconf is one of the programmability features on the latest platforms. And this is how I usually double check that my lab is up and running and like I can programmatically access it. So I usually run the script. So you saw me put all of these configs right from like text editor and then starting all of that. And then I run the script, which basically does curl on every device. And you can see that I got the host name back from all of these 10 devices. So I am able also to connect to, let's say, SSH port. Yes, Cisco. So I am on router 2 right now. So I'm able to access all these devices programmatically, which is a very big deal to me. So I can put Dmitry approved here with a stamp. So, all right. So the question that I had for you, Ralph, is that you mentioned something about securing the console access. So what you're saying is that I can no longer tell NAT to this IP address and some specific port to get to the console. Is that what you're saying?
That's a loaded question, right?
maybe.
No, you cannot.
So how am I supposed to work with this product?
Oh my God, yeah, you cannot. Well, you actually can. So as I said, there's multiple ways to do the same thing. And for console access, there's 3 different ways. As I said, the UI specific part, in the UI directly going to the console, and to get to that thing, you have to authenticate and everything is encrypted, right? Then there is a terminal server, so you can actually SSH to the box on standard SSH. And then you do get a terminal server that connects you to the console there. And to get to that console, you need to authenticate, and SSH is encrypted. So that should be all good. And the third way is what we call, or uses what we call the Breakout tool. And the Breakout tool, again, is using an encrypted and authenticated session to your VIRL server, and it breaks out those console sessions locally to your machine so that you can use your secure CRT, for example, to connect to a specific console by connecting to localhost and on a specific port that can be mapped out locally. So this is the terminal server. This allows you to select a specific lab, so you can now do an open and then select the lab ID. So it uses kind of a path notion, so like slash and then the lab ID you can tap or double tap, and then you get a list of, you can just double tap.
And then I put
and then in the tab again, and then you can cursor to the actual node that you want to connect to. And the serial line, the lines there are 4 nodes that are multiple serial lines. So rather you would get on the West, rather you would the Oxford and on the machines on the XR 2000 up to 4.
You're breaking, Ralph. Your audio is breaking, unfortunately. Yeah, so I will explain. So I SSH to VIRL machine with my web UI user, and I have these consoles here. So this is one of the available options. And another option would be to console directly in the browser, right? So like I can select the node and I can open console. You can also like resize this. And this is your console here.
And if you now go back to this other thing that you have opened in your SSH session, then you will see that this is kind of echoing. Like go to router 10 on the web UI.
Yep.
And then go back to your terminal window.
Oh, what did I do? Hold on.
I'm not sure what you did.
Okay, so I open router 10.
Right, and if you now go back to your web window, to your SSH window.
Yep. So yeah, this is control.
And type something in there.
Nice. Okay, so this is console multiplexing, right?
Correct.
And this last piece, last way is Breakout tool, right? I thought
that's the third. Yeah, Justin is going to fix that anytime soon. Like not for 2.0, but for the next release, we are going to fix that and have a more consistent navbar, which is desperately needed.
Okay, so if I install this, right? So if I install this, I should be able to connect to my VIRL server and have local consoles, correct?
Correct. Yeah, the easiest way would be just to open up a console or a CMD window and open it from there with the space UI flag, and it'll launch a web interface.
Yeah, you know what, it will probably take some time for me because I need to go to their binaries and then start it, right? And then UI will pop up. Or actually,
you should be able to open just like a command prompt window and drag the download over into it.
Okay, so if I open...
No, you need a CMD, not an SSH. Well, okay.
Yeah, that's it. And then just go
and
to
I need the binary,
or
yes? I need the binary.
Yeah.
Yeah, I will need to re-download this to proper place. And I will save it like as a breakout or something. Yeah.
Name doesn't matter.
Yep. So I have it here, and then god damn it, and I keep forgetting how the pass works on.
Don't you love Windows?
Yeah. It's like this. Is it backslash or forward slash?
Just
yes,
use
I did it. Okay.
Just use CMD.
No, dude, it's not a programmer way. Okay, so if I have breakout and then what was the flag for
just,
the UI?
Space UI, but you need to specify exe, don't you?
Yes, breakout.exe space dash or space UI.
UI, yeah, that's it.
Like
just UI.
Okay.
Yeah.
And then you point your browser to that 8080 address.
Yeah, so if I say localhost 8080.
Right.
And then I need to set up the configuration, yeah. And then this is correct, but this is incorrect here. And then yes.
Probably you remove the verified TLS. If you haven't installed a cert.
No, I did not. Okay.
And then hit the refresh button.
Yep. So I have
there
this.
You go. And now from this point on, you can statically map, and you could say, okay, I want to have my router 1 always on port 9000 or something else. So, and in this case, you would always get, if you telnet localhost port 9015, you would always end up on router 1. Yeah, you have to start it first. You have to hit that button at the top level to start it. So if you go back to the labs or all labs. and then hit that button to turn it on. What does it say?
It's just one device, so my socket is
Will be used by something else.
Yeah.
I think that has to be telnet though, not SSH.
Yeah, that's correct.
Did I select SSH? Yeah, I did.
Yeah.
So localhost 9000. I don't want server. Let's do 9001. Actually, I can do it directly from here. So if I say, if I have telnet installed, telnet localhost.
So router.
Okay. I
Yeah.
have
So
it
there you go.
Okay. So, and the reason why you do that is that to provide security that no one can access those consoles remote. Don't expose them, correct?
Yeah, so the reason for this is that a lot of users want to use their local applications to access the thing, and they are not happy to use, let's say, the terminal server, or they don't want to use the web interface. They want to use their native applications like, multi-tab PuTTY or iTerm or Secure CRT. They have the ability to type into multiple devices at the same time, and like those advanced things that you can do with these kind of terminal applications, and to have that being done in a predictive way where you always know, okay, my router 1 is always on this port, my router 2 is on this other port, and so on and so forth. We use the Breakout tool to map this out specifically so that you always get a consistent result. And as a side effect, since we're using that WebSocket that goes back to the VIRL server, this is all going to be authenticated and encrypted and therefore secure. And you minimize the exposure on your server as well. So that was one of the bad things in the past when we actually got dinged a lot from our InfoSec folks, where they said, hey, we are seeing these routers on your lab network, and they all have Cisco as password, and they are like totally insecure. Yeah, they're running in a network simulation, but InfoSec doesn't care. So in this case, you would not get to any of these consoles or router devices inside of a running lab because everything is kind of, shielded off and minimal exposure.
Absolutely. And we've got people who have used like bare metal cloud hosting providers. So Packet.net was a common one for VIRL1.
Yeah.
And you could be exposing a lot of things there. Or if you're using it in a corporate environment with Cisco Modeling Labs, CML product, having those ports exposed would be security through not even obscurity kind of thing. Like you could hit port 9000 and probably hit a device. If it had a crypto on, like the password change, then you'd need to hit it, get that. But this basically breaks it out per user. And also the ability, previously you had to, if you want to change those ports, so I know people would have maybe you'd have a 4-node ISIS lab and a 4-node OSPF lab. You'd have to shut down one to be able to hit the other one if they both have the same port numbers. So being able to reconfigure this dynamically on the fly through that UI is really nice, because you could have both labs running and both using that local mapping, and then just switch back and forth without having to even touch the simulation. You can just tweak those things in the Breakout tool. So a lot of those things are, it's decoupled. So you don't have to shut down the lab to make those modifications. So it brings a lot of simplicity. And then if you want to do programmability, you can just get that local port without having to do any of the extra forwarding, but you still get the authentication and encryption. So lots of benefits.
Got it. Nice. All right, we are almost coming to an end, but there are still a couple of things that I want to talk about, at least briefly, and there are still a couple of questions. So the question was indeed about the YesNet SIEM. I don't think the stream is the right place to ask questions about some internal tooling. So if you're interested in that, reach out to Ralph or someone and talk to them about internal tool. Staggered spin up for VMs, correct? Can you host VIRL2 on PaaS provider like Heroku? I think the answer would be no, correct? Like you need to have either integration for that, or you actually need some kind of infrastructure as a service, actually, right? To spin up the to set up the VIRL and stuff like that?
So we do rely on the CPU capabilities to run virtual machines. So that basically rules out pretty much all of the traditional hosting providers which do offer virtual machines to start with. So we, as Simon said, we can run something like this on a bare metal hosting provider. So there are some flavors on AWS that do bare metal, and I think like also on GCE, I'm not sure, but certainly like Packet.net. But we do require that hardware acceleration support of the CPU. So right. even though that some of those service providers do expose the VMX flag for Intel CPUs in their platform offering, and sometimes it's just the third level or something like a L2 hypervisor or like an L2 that just doesn't expose their, like it's only limited in terms of how deep hardware acceleration can go in a CPU, and then you would just really get super slow performance, and it's just not usable at that point.
Yeah, but there is also one benefit here, since remember, folks, I mentioned that like how the whole installation process manual took me around 12 minutes. So we're talking about something like Packet. I remember in VIRL1 when there was this like partnership, right, between VIRL and the Packet, where you had like some setup scripts or something, and I remember like it also took quite a long time to get it up and running. Now you don't really have that problem anymore. Like me manually typing on this stuff took 12 minutes, but if it's done automatically, then it's going to be even much faster. But I guess the answer to your question specifically about pyATS and Heroku would be no, right? They don't really expose that level of virtualization support that any kind of network simulation software needs, right?
Yeah, I don't think so.
Okay, cool. Now, the last two things that I would like to discuss, and folks, if you still have any questions, this is almost your last chance to ask them. So one of the things that I was able to go to is API documentation, and we also will cover a little bit about client library. So if you go to the API documentation, you end up on Swagger page, and pretty much everything that you can do in the UI, you can see here in the API, because everything is API driven. So, and I think if you want to test it, you need the JWT token, right? You need to copy it, authorize here, and then you're able to like actually test this in the browser, like get the labs. This is just lab ID, yep, list of labs, response. Can I get details for a specific lab? So it would be what, get lab ID.
Should be the option, yeah.
Yep. So if I execute, yeah, now I get like, this is a test lab which is stopped. So stuff like that. So you can very easily explore APIs, and you can see there are many of them, because again, everything you see in the web UI, you can drive through API. So that's pretty nice. And then this last piece would be the client library. Yep. So what is this?
Yes, the aim was, so we've got the REST API exposed, but you have to do the authentication, and you have to get the right commands and everything like that, which is fine if you want to build against that REST API, and you get all the features there. But what we tried to do is make it even simpler, which again is that overarching theme of what we're trying to do here, is make it simple to do common tasks. So if you go to the examples on the left-hand side, under the menu third from the bottom, yep. Basically, this is showing just a very simple usage of it. We've given previous classrooms at Cisco Live that are available to look at as well, with a full featured run through of all this. So basically what you do is download this package. It's almost on the Python package index. Ralph's almost got that going, which is awesome. So you should just be able to pip install the client library, and then you can connect to it. So you're just basically saying create a session, IP address, username, password. That's all pretty straightforward. It's not yet. Tips, so Not yet.
Okay.
Very soon. And by the time the product comes out, we'll hope to have it up there. So you can basically create the session, and then we've got that block here. So further up, there's some other examples in there. People have integrated it. So there's the first big block of examples, probably the key one we want. If you scroll up about a third of the way down the page.
He's so curious about other things, it seems.
You give me the mouse. So go to the first example, please.
First?
Yeah. It
This
proves
one?
we didn't rehearse it. This is realistic. Yeah, okay, and scroll down a little bit to where we create a lab and add nodes. Yep, that's it. Okay, so we create the session, and then what we can do is just create a new lab. So lab.create lab. We can add a node. So here we're adding iOS V. We could add any other device that's on that list that we discussed before, or if we added our own, we put in the ID. We can set the config. So instead of where Dimitri was typing in the box before, we can just set the boot up config there as either a single line, pretty trivial example here, or multi-line config, or we could splice that in from a external file just using Python read and standard scripting. We then create a couple of interfaces on that, create a link between it. So essentially in about 8 lines of Python code, we've created a lab with a couple of devices connected to each other and with configs, and then we just hit lab start. And that lab start will use the whole launch sequencing. So if we've got lots of devices, it will stagger the launch and set them up reliably. And then what we could do is put in a loop that says while not lab.booted, and then just sleep for 5 seconds. And then that will wait until each of those devices have told us that they've reached the booted state, which comes from that boot progress monitoring, which comes from the console multiplexing. So once each of those devices have come up with that predefined string that says press enter to begin or whatever it is per device, and we know that device is ready to interact with, we can just sleep until they all say, yep, I'm ready to go. And then we can do something. So as an example later on of using NetMiko, you could use a pyATS script, you could do whatever kind of interaction you want to do. And that's all built entirely just using a few lines of Python. So everything's accessible here. And as Justin mentioned way at the start of this call with the user interface, everything is real time because it's all on the server. So if we ran this script here and had a browser window open next to it, we would see as we create a new lab will pop up on the lab titles page, and we'd see the nodes being added, the links being added, the nodes happening. So not quite multi-user, but multi-theme interaction. So in this case, if one user using the UI and the client library, they all use the server at the same time. That's all streamed in real time. So we could interact with both, and we could add a new device in the UI, and then the next time the client library does a command, it will pull the latest topology down. So we can interact with both seamlessly in real time. It's not like you've got one or the other. So that's quite nice to see what's happening in the scripting example in the UI. But essentially, we've tried to narrow it down here to be very, very minimal lines of code. So the REST API is nice, but in the Python client library, we make it super simple to do common things. So even people who are just beginning with Python can get started on using the API to program. Or then you can use this as part of the CI/CD workflow, and this is what people have built, things like the Ansible module, or where we'd go with the Terraform plugin would be building on top of this. So it opens up a lot of third-party integration, but it also makes it very simple to get scripting. So Dimitri early on said he found it a bit tedious to have to connect all those nodes together. We might add some stuff in the UI to make that easier, but here he could write a for loop in 5 lines of Python code to wire all those devices together. So really trying to make it simple to script against the program and do all the auth and everything like that out of the box. And this will be available on the Python package index very soon. At the moment, you can download it within the software, and install it there. But yeah, it should, again, it's just trying to make programmability super easy, which is a real focus of what we're trying to do here. Make the UI easy, but also programmability an option.
Yeah, that's pretty nice. And I also think this is something that, well, a feature that stands out as well. Like, I know that a lot of other products are like API driven, but here is not only API first is design where everything is available by API, but also all of these tools are available on release, right? And they are not community driven, they are built by VIRL team. So you can, on the date of release already, do all of this, some cool network automation, specifically using using this library, which is already available. And Simon, I think one of the last questions here would be around this client library. I heard something around pyATS, and NoSiming didn't pay me to mention pyATS. So I heard something about pyATS and Ansible integration. Do you mind clarifying that?
Yeah, so there's a couple of different aspects. So the Ansible integration is building on top of this. So where we've got the commands here to start nodes, add nodes, etc. The Ansible plugin or the Ansible module is essentially wrapping around that. So you can use Ansible playbooks that then implement against the client library, which in turn implements against the REST API. So they've wrapped it that way. Use an Ansible module that way. We've also got pyATS in a couple of different ways. So we use it underneath for interacting with devices. That's how we do the extract config. But then we also provide the pyATS testbed YAML that you can download. So I don't think we've got an example here, but if you actually went back to the Swagger UI, we probably would have to figure out we here is sync test get testbed. Or in Swagger, we can see it there as well. So essentially what we're doing is you've described in your UI a topology of routers, switches, and links between them. What we will do is generate the YAML file that you use with pyATS to plug straight into there. So with pyATS, you have your set of test scripts you want to run, and then you've also got the YAML file, which describes the test bed, which is the topology that you want to interact with. And what we generate here through a single REST command, and Dimitri scrolling through, is that set of devices in the testbed format that you can plug straight into pyATS. So we just made that again easy to use. We've already described it like once. It's just there. You can grab that, download it either through the client library or REST call, and use that straight into your pyATS scripting.
Awesome. Yeah.
So if you're looking at the client library documentation, there's also in the introduction there is also the link to the Ansible plugin, if you like the third paragraph at the top.
At the top?
Yeah, there.
Oh. Okay, so there is an example playbook to drive VIRL, basically, correct?
Yeah.
Awesome.
It's not an example. It's not a playbook. It's actually a plugin that enables you to write playbooks.
Got it. Okay. Very nice. So yeah, things like this really simplify life of network automation engineer or whoever is starting with this, right? Like you can spin up your lab in Ansible. You can generate a test bed, which is quite actually tedious to do by hand, especially if you're just starting, right? Like you don't have to do anything. Just here is just one simple API call. Here's your test bed that you can use. So things like this really simplify life. So me as a network engineer, I'm quite happy to see features like this. And yeah, I think this would be a good point to wrap up. Folks, if you have any last questions, feel free to type them in the chat. And meanwhile, let me do a quick summary, and we will also go around our virtual table to say a couple of closing thoughts. So today we went through VIRL2 and talk about stuff like history and its architecture and so different features. I really do think it's really impressive. I think one of the best thing that VIRL provides is that out of the box experience, like how you actually get your lab up and running. Like you don't have to care about how do I get the image, how do I upload it. You don't need any of that. Like it took me 12 minutes to get from the installation till the lab up and running and ready for my scripts, which is very nice, right? And you can take lab from anyone, load it, and then also you have that exactly the same experience, which is also really nice. So there are a lot of features we covered today. A lot of them are very interesting, and something that is not present in other products. So I'm very happy with VIRL2. I'm looking forward to the release date. I hope it will be very soon, so others can use it too. Yeah, this is what I have to say about VIRL. So let's go around our virtual table and then a couple of closing thoughts or whatever you want to say. So let's start with Justin.
Closing thoughts on what?
On anything you would like to either add or just yeah, maybe we missed something that you would like to mention. If not, you can just remind people with your handle.
I think we covered most of the things that I want to cover. I think one of the things that I'm most excited about really is the Breakout tool and just the different ways that you can connect to the devices, as well as the API and the client library. I think there's a lot more things that we can do with the client library. Obviously, we can't cover all that on this call, but I think it's one of the really powerful features on VIRL2. Yeah, and if you want to follow me, I'm on Twitter at Breaking the Web.
Awesome. Yeah, actually, this is really nice, Justin. Let's, on top of closing thoughts, if you have one or two features that you really like in VIRL2, I would also like to hear them from you. Right, next one is Justin, Ralph.
Yeah, what to say? I think it has been, for me personally, a very intense and very interesting last 3 years or something to get to this point, to get so close to have something shipped. And I don't know if you guys can imagine what it actually means to ship a product, and to build a product and to ship a product within a large company like Cisco. So it's sometimes really very interesting to tick all these boxes. But the exciting piece here really is that we are so super close to get this out of the door. So that is really the thing that keeps me going. So that is I'm really looking forward to this thing. And there are so many ideas right now floating around. I guess we have probably ideas for, even if we release something every 3 months, which is the plan, right? We probably have ideas for stuff that would easily go for the next 4 years, even with a 3 month release cadence. So that is very exciting, and all the momentum that is currently going on in device programmability, in network automation, in CI/CD, in network as code, and in all these different areas. A tool like this is kind of the center of it, to integrate all sorts of different other tooling. We heard about Terraform, we heard about Ansible, we heard about NetMiko, but there's things like NSO, there's things like other controllers or identity solutions or security solutions. I mean, that entire security space is so big for Cisco, and currently it's one of the biggest growth markets. And that is a software play. So a software play basically means that it's very well suited to run inside of a network simulation and to give customers the confidence into the solution. And I think it's a very bright future for something like this. And we have a lot of ideas how to improve this, and that is going to be very exciting. So that's, I guess, my view on these things. And I'm super happy to get this out of the door and to have you guys actually use it and provide feedback and feature requests and all of that stuff. Yeah, end of story.
Yeah, awesome. Thank you, Ralph. Simon, you're the last.
Yeah, so similar sort of to what Ralph was saying, it's great to finally get it out. And a lot of work, and we've showed demos in the past, but the amount of work that's increased, the amount of work that's gone on between each one, and some of it's behind the scenes in terms of robustness and architecture, has been huge. It's been a lot of development on it. 2.0 is going to be really good, and what I'm really excited about is the effort we've put in to design it so that it's possible to add a lot more stuff in. So we saw the pyATS testbed, or we saw Ansible integration, but the way that we put the effort into getting these underlying pieces right sets us up in a really good way to go forward. So there's a lot more we can do in the user interface in terms of workflow. We're trying to get a lot more in there in terms of, you know, displaying interface names, how we display the links. There's a lot more that we can do. So probably what you see in 6 or 9 months will be very, very different to what we've got here, because there's just so much potential and potential velocity in terms of feature development. We're really excited to get this out and to build up those conversations with the community and get the feedback about which aspects we can improve on or add new features. So I'm a bit reluctant to give out my Twitter handle after saying that, because there'll probably be a ton of feature requests. So we are working with Vern, the product manager, on building some ways to be able to collate that feedback from the community and get those real features captured in a way that we can start building it in. But yeah, it'd be great to get it out the door. And then once we've done that big step to get it out the door, we can start to really iterate on the development going forward. And probably the final thought is, it's been really good to have such a vibrant internal community. So we've always had a good community of users of VIRL version 1 within Cisco. But we've got about, I've lost count, maybe 400 Cisco staff using the VIRL2 product internally. And some of those well, they're people from all across different business units and doing different things. And that's really starting to build some momentum for future collaborations and things like we're talking about, reference platform features or integrations with other demos and tooling and things like that. So I think that really helps. We're trying to build the community on the external side, and you know, Dimitri's done a fantastic job in helping sharing some of the ideas there and things like screencasts, and also internally as well. So I think the growth rate here of having this platform is really starting to pick up, and that's really awesome to see. I think we've got a good basis here, and we can really take it somewhere really exciting going forward.
Awesome.
But yeah, it's a very bright future, and we're really looking forward to hearing community feedback, and hopefully not too many feature requests, but that's always a good problem to have.
All right. Thank you, Simon. Yeah, and from my side, I can say that, well, after my interaction with Ralph, Simon, Justin, and also trying the product for the first time, they managed to convert me from skeptic to believer, which is a really hard thing to do. So kudos to you folks for building such an amazing thing. And it amazes me the most from like architectural standpoint, since I'm a software developer. And I also like all of these different integrations that you have, and also the things that you have on your mind. So I'm also really looking forward to the release and the feedback, and all also looking forward to the features that will be in like 2.1 and 3.0 or whatever. Yeah, I really believe there is going to be a lot of really, really cool stuff. And I already see for myself that VIRL will be a key piece in my NetDevOps workflows for, like, you know, testing, spin-up test environments automatically and all of that. So yeah, looking forward to the release. With that, folks, I would like to thank everyone. I would like to thank our guests. I would like to also thank Cisco VIRL, well, the whole team, not only engineers, everyone behind the product, Learning at Cisco, and Cisco DevNet for continuous support. And with that, thank you so much. Recording will be up as soon as I can, and I will see you on the next stream. Goodbye now.